Today we're joined by Kevin from Plumgeek Robotics. Hi, Kevin. Firstly, thanks for joining us for this interview.
Yeah, thanks for having me.
Okay, so tell us a little bit about your current Kickstarter project, Wink.
Well, we launched it. We're about halfway through the campaign right now. Things are going really well. We actually hit 1,000% funded this morning, so that was pretty exciting. We were the idea was to build a real simple robot that would be real approachable to try to start teaching the basics to people that are new to programming that might not know anything about programming.
Right.
Basically, kind of the basic structure of the language, and just we tried to make it as approachable as possible. And we're going to see how young of kids we can actually teach this to.
Sure. So what kind of languages is this going to be applicable to, as in programming languages?
Well, it's the Arduino development environment, if you're familiar with that. But Arduino, it's basically C, which is the common. If you write code for anything that's on a microprocessor, C is really common for that. There are some other languages you can use, but C is really common in the world. It technically is C++ also.
Okay.
We won't get into that a whole lot in our teaching, but the kind of the core foundation that you'll learn going through the lessons will definitely get any kind of student prepped for learning like Java.
Right.
What was the other one?
Python and things like that.
And Python, yes. So the foundation will kind of get kids in. The foundation will get people prepped for learning Java, Python, and other sorts of real-world programming languages where they have to write code. A lot of the key concepts transfer over well.
Right. So basically, when they pledge for the project, they're getting one of these little bug robots, and they're also getting a curriculum. Yeah,
that's right. That's one of the main things we're trying to do. Is we've written about probably 5 or 6 of the lessons right now, all the way through. And we're going to get up to about 20. And so the idea is that all the lessons are, you can print them as PDF or just read them off the screen. And then we're also going to do a set of companion videos that go along that we'll make a YouTube playlist out of. And so even if the teacher or whoever's conducting the event or whatever doesn't know anything about programming, they can just real quickly set this up, get the robot set up. They've got the lesson plans in front of them. They can see a little kind of like a guide video that goes along with it. And then they can be there just to kind of help the students along. But it's designed to be really easy to start a class without having to go through a lot of training or learning ahead of time.
No, because there's a lot of people out there that they always say, "Oh, I wish I could learn to code, but it just seems so complicated." This seems like a very a fun, easy entry into something like that.
Yeah, that's the whole idea. I think that there's a lot of great programs that are out there. That are kind of an intro to code where you're doing things that are on the screen, but having something that you can actually hold in your hand and play with and kind of see it actually react on your desk to different things you're programming it to do. I just always thought that was really interesting. I've always been into tinkering and playing with robots for as long as I can remember. So seeing something actually go around that you control I always thought was really engaging.
No, when I first saw it, I pictured a lot of people attempting to kind of teach kids to code using a variety of methods, but I really think this is kind of unique because it's not a toy, of course, but it's almost like a scale extra that you can kind of program to do different routes. Yeah, so talk us through the kind of functions that this thing has actually.
It has. I've actually got one of the little guys right here.
Oh yeah, great.
It has, let me just kind of go through it here. It's got 2 big color eyes,
yes.
And you can change the eyes to any color you want. You can set them independently, and that's actually the very first lesson. That's kind of how I got my kids started with programming way back a couple years ago, just making a light change color. And once they figured out they could make it change from one color to the other, they just started writing all these different color sequences for it. So that'll get them started right there so they can play with that. There are 3 ambient light sensors on the front that detect. They're so small you can't really see them, but they detect light straight ahead and then to 45 degrees on either side. So you can do light seeking, light chasing and stuff like that. On the bottom side, there's 4 line following sensors on the bottom, and so it can pick up like lines on paper, and it'll be able to do the standard line following that you see educational robots do. It has a little infrared headlight on it that it sends out an invisible infrared beam that will flex back off of surfaces, and it can be picked up by the ambient sensors, so it can see if it's coming up on a surface. without having to. It's actually a real simple little thing that it does, so it can stop before it gets to walls or whatever. It's got a tone generator on it. It just makes it's a simple on and off. It doesn't really play music or anything, but it's it's something to give you a beat or whatever as a feedback. There's a button on the back so you can make it react when you do certain things with your button. So you'll learn how to read inputs off of just a simple button like that. And then the two motors these are just little, we call them pager motors. They're basically the same motors they used to put in the old Motorola pagers for the vibration.
Okay.
It would they'd hang a weight on the side, and so when it spins, it would vibrate. But you can have them made without the weight on there. And it turns out they actually work out really well to push the robot around. So it just runs around on the little shafts. You really probably can't see them in the video there, but it's just the tiny little shaft touches the ground, and it runs at high speed, and it makes a little tiny contact patch with the ground. So it kind of forms like a natural gear ratio.
Right.
And so it's kind of almost, when we started testing them, it was almost kind of made for that application.
So it's kind of like low friction then, isn't it? Because it's got a small contact point and it spins around really fast. So I guess this thing can go pretty quick as well.
Yeah, it'll get up and go across the room pretty quick. You can control both motors you can set them to any speed between 0 and 255 and the frontwards or backwards direction. So you can basically make it move any way you want. If you run them in opposite directions, it'll spin really tight on the desk. It'll spin really fast. You can see that in the Kickstarter video. And if you put them both at full speed and you push, set it up to, when you push the button, it'll take off. It'll take off pretty quick. And that's actually one of the fun things we have set up for, I think it's lesson 3 or lesson 4. The kids learn the eyes, then they learn how to make the motors go, and then they learn how to read the button. And then we kind of put all 3 of those things together, and we make it a little drag racing robot. Right. And so if you have 2 of them together, you can line them up and push the button at the same time and see them both take off. And then you can kind of tune, which motor needs to go faster or slower, and how fast you want it to accelerate so it doesn't spin out. And so you get to kind of play with it and tune it a little bit.
Oh, so it kind of turns by one motor spinning faster than the other one.
Yeah, you can create turns by, if you set one motor to go forward at, speed 50 and the opposite one is at speed 100, then this side's going to travel faster than this side, so it's going to curve this way. And there's no onboard, there's no gyroscope or anything to actually maintain its heading on this robot. Our Ringo robot, which is more complex, does have that, but this is just designed to be really simple. But inevitably, you'll always have one motor that'll be a little more efficient than the other. So if you set them both to, say, speed 150 and you let it go, you might get lucky and it might go perfectly straight, but in a lot of cases you're going to see it veer off one way or the other.
Right.
And we actually talk about that in the lessons, how that works, and then you adjust one of the speeds a little bit and you kind of play with the trial and error until you get it, and then you got a nice, pretty much a straight line going at that point. Okay,
so how did you come up with the idea of a robot that's going to teach kids how to code?
Well, this kind of came off of the tails of our previous project for the Ringo robot, and that robot, it kind of started as just kind of a funny little thing. We were having a discussion as a family, and we said, I was already in the business of, we used to make radio control equipment for camera lighting, so I was already, comfortable designing circuit boards and designing up our own stuff, building our own stuff. And so we were talking about building a robot, and we were going to go get like all the, the different pieces and parts you can get online and kind of put it all together. And I said, well, what if we made our own custom one as a family? And, I'll go out and get a couple boards, I'll hand solder a couple of them together, and we'll have them just to play with as a family. And so that kind of really got us thinking, and there wasn't really anything out there kind of like what we wanted to do. So we said, maybe we should get serious and try to, really do the best we can. And so the Ringo robot was actually based on this design from a company called CrowdBridge, which is a company in Canada. Okay. And they're kind of famous for making these robots called beam robots, which is BEAM. Okay. They didn't actually invent the concept, but anyway, they're basically real simple little solar powered robots. They're great kits if you ever want to just get into just soldering and just playing with stuff. They don't have a computer processor, but they're simple, like little light seeking robots. Right. And so anyway, they were the ones that kind of gave us the idea for having the pager motor design. That's how their robots are designed. Oh, okay. And so I said, well, and you run it with a solar cell, and they move fairly slow. If you put a bright light on them, they'll move all right. And so I thought, well, I wonder if it can carry some weight around. So we put some batteries on one of the robots that we'd actually gotten from them, right, and turned it on. The thing just took off across the room, and we were like, oh, we're onto something here. We can make this thing go fast. And so anyway, the Ringo robot, the whole idea there is we said, let's find out how much weight we can carry around with these motors and have it still be nimble. And we'll just pack as many sensors and smarts and extras in there that we possibly can, given the space constraints that we had. and we'll just try to make it like, as cool as we possibly can. And so that did really well, and that was more, I think that's probably a better fit for people that are already into programming and kind of hacking and building their own robots and stuff, because it kind of takes all these big parts and puts them all together onto one tight little board. But it's something that you could begin with, and a lot of the people that backed that on Kickstarter, I think that was kind of a starting point for them also. But we knew that we wanted to make something a little simpler and lower cost, so that we could kind of be more of an entry-level point for everyone. And this actually came out of a conversation that I had with a teacher from one of our local schools. We were doing a mini maker fair a few months ago, and we kind of brushed on this idea with other with other teachers along the way too. But we got to talking, and she was saying, well, we have these robots that we teach kids the basics with graphical programming. There's a system called Scratch, which is you can Google it up, and it's a real you code by dragging puzzle pieces together that do different functions.
So it's like a GUI style rather than code style.
Yeah, exactly. There's that, and there's a few different versions of it. There's Scratch, there's Mini Block, RG Block, the Lego robot system has a programming environment that's similar to that, and so that's where a lot of people would get their start. But we started talking, and she said, well, I would really like to start getting kids into like actually writing real code, but C, we can't really do that because C programming is so complicated. And so I really started thinking about that, and I said, well, it doesn't really have to be. We can write functions to do a lot of things, and if we can just demystify the whole idea that writing code is somehow hard, and we can maybe get their feet wet with doing something that's actually not hard at all that anyone could understand, then that might kind of get them thinking, well, maybe I can do this. And so we talked about what price point would it have to be, what bare sensing would it have to have, like what would this thing have to have. And so we had this probably half-hour long conversation where we kind of just kind of thought it up, and then that next week. We went and we actually had another robot called the Jerry, which I'll show you. Let's see if I have a Jerry here. You're going to edit this anyway. So you can
of course, no problem. Yeah, find the Jerry.
All right, so this is Jerry that's missing. This is Jerry that's missing a feeler. My daughter dropped it on the floor, and we realized that if we ever actually make this, we need to make this part thicker because she dropped it and it snapped it off.
Right.
But anyway, it was a double decker. The whole idea with this one is that you're going to solder it together yourself. It was kind of a scaled down Ringo also. And the whole idea is that you'd get it and you'd be able to solder it together yourself. And when we were building the Ringos, we had such a hard time getting. I won't even go into that, But anyway, the idea was that you'd solder it together yourself, and it'd be a fun little kit robot. And we were about to launch that, and when we had this conversation, and then that Monday we came back in the office, and we were all just kind of doing our Monday morning thing, getting our coffee, and just talking about the weekend or whatever. And we started really getting to talking, and we thought, maybe we should put this Jerry thing on hold because we had this conversation over the weekend, and maybe there's something to this. And so we went to the whiteboard and we started just scribbling, and we kind of came up with this concept for the Wink robot. And we were like, well, we'd have to have this, and we could get rid of this and get rid of that. And it was really hard pulling features out because we were trying to keep the cost low. And we were like, we really got to stick to the task of, what does it have to teach the basics? And then once they have the basics, then they can go on and get another robot that does more stuff. But for right now, we got to keep it to the basics. So it was almost painful to be crossing off all these features on the board. Like, I really hate to let that go, but it's like, if we're going to hit the price point and everything, like we have to do it.
Right.
And so after probably maybe a 2-3 hour discussion at the whiteboard, we had it designed. And so I kind of pushed some stuff off the calendar for the next couple of days, and I just turned up some music and kind of focused on it. And we had the whole thing completed by probably late day Wednesday. So from idea to ready to order prototype was 3 days.
Right.
So that was pretty quick. I
was going to ask you that. I was going to ask you to tell us about the development process of the Wink. From inception to prototyping to launch, and you pretty much from all the skill set that you built up in a career of what you mentioned, the remote programming stuff, you were able to put this in a matter of 3 days. You had the first prototype there, right? Obviously. The final prototype was different to that one, right?
Yeah. Well, the way I work is I design it all in the computer, So we've got a pretty good feeling it's going to work at that point. We start off in SolidWorks.
Okay.
And SolidWorks is basically we create all the solid models, digital models of all the parts.
Yes.
And we're reusing a lot of the parts from Ringo, so we didn't have to create a lot of things like the battery, the motors, the motor clip, everything. That was all already there. And so we created models like for the eyes and stuff. And so we just started kind of on the screen, we just start kind of moving parts around and just saying, that looks good, or no, that's going to be out of balance. And it started off where everything was all up front and the motors were in back, and we realized it was going to drag the nose so much that it wasn't going to be able to move. And so we played around with it. And then once we get the solid design correct,
yes.
Then I go over into the circuit design and, get the schematic, and then we put it all together. And then, at that point, we think it's probably going to work. And so I ordered the boards to get a prototype made, and that takes a couple weeks to come back. And then when they came back, I hand soldered a few of them together and started. I already had a lot of the code written at that point because I kind of knew what I wrote it just based on the schematic that I could see. And so we got to be able to kind of play with them right away. And then we started filming the Kickstarter video probably 3 or 4 days after that. So it's been a pretty quick development.
I mean, that's definitely, that is super quick. But I guess that all comes, again, from another question I was going to ask you was, what lessons you learned from not just the first campaign of running a campaign, but all of your experience in developing from prototype, from inception to prototype to launch, and what lessons you learned from the Ringo and how that kind of helped you with the Wink.
Yeah, well, over the past few years, not in robotics, but we've built a lot of prototypes. So for various other things that we've done. So there's been a lot of mistakes made along the way and a lot of lessons learned. So I'm pretty familiar with the software now. So that part was pretty easy. As far as having high confidence that we could take an idea and take it, we kind of take something that we already know works and then finish it. With the Ringo, when we built the very first Ringo prototypes, let's see what problems we had with that. It wasn't really a problem, but the light sensor, I had never built an accurate light sensing circuit before, so I kind of hacked together something that worked just for the prototype. And then after that, we went back and redesigned that. When I almost went straight to production on it too, because it was in theory it was pretty simple.
Right.
And I said, let me spin another prototype just to make sure. And it was a good thing I did because I had the LEDs wired backwards. So little stuff like that happens. So if you make that little change, like whatever it is, don't go ahead and just take the time to order another set of boards, make it again, and just make sure it works before you go order 2,000 boards or something like that.
Right.
We didn't really hit any significant snags in the Ringo. The Ringo pretty much worked the way we thought it would, which was really incredible. It was fairly complicated, and we hadn't really tested a lot of the stuff before. But one thing I will say is that being open source, we used designs that we got from other places for a lot of the parts of it. So there were some boards that were available through Adafruit and SparkFun.
Okay.
There might have been another one out there. But so like the accelerometer.
Yes.
Rather than going and saying, there's a bunch of accelerometers that we could choose, let's go and see one that's already being used in the open source community.
Right.
That already has a reference design for it, already has maybe some code written for it, and then take that. And that's kind of the whole idea behind the open source world is that, there's no need to go out and reinvent the wheel if somebody has a solution that already just works.
Right.
So that saved us a lot of time and effort right there. Let's see what else lessons learned. I'm trying to think if there's anything else exciting.
The Ringo was your first campaign, right? Am I correct in saying that? Okay, so obviously,
that was Kickstarter.
Obviously, you guys are pretty experienced in knocking up prototypes, like programming, getting the software, the SolidWorks to do your modeling, and then getting on the board design software. But when it came to actually getting on this new wave of crowdfunding, how did you? Did you face challenges? Did you everything you expected? Is that how it went, or it was kind of different?
It was kind of a process. I first became aware of Kickstarter. I started hearing about it a few years ago. A couple of my employees were on there, and they would back little things that they would get, and they would they'd show it in the office, and they'd be like, "Oh, I got this on Kickstarter," and I didn't really even understand what it was. And then one of the guys that worked for us for a while started a business where he was cutting out these veneer coatings, like wood veneer coatings for laptops.
Okay.
And he needed a laser cutting machine for it. And so he was like, oh, yeah, I threw up a Kickstarter, and he got whatever he needed. And so I thought, well, that's pretty amazing. You didn't have to go out and run up a credit card or anything,
right.
which you probably could have done. But, he went and did this, and he was successful. There was another guy that did some video work for us for a long time who does game design on the side for like iPhones and stuff.
Okay.
And he had a couple successful Kickstarters for that. So it's like I kind of seen success happening.
Right.
And then we started thinking, well, doing the robot thing, well, this is an obvious, let's give it a shot. And so we went and started looking around on Kickstarter and the technology projects, and we were seeing that, quite a few of them were doing pretty well. So it seemed that in general, if the campaign was put together well, and it was kind of an idea that somebody would probably want, that in general they were doing pretty well. There were some that I was finding though that I thought should have been huge successes that weren't really getting off the ground. So I don't know what the story was on those, but so it's not necessarily a rule. But the big challenge that we ran into with doing the Kickstarter was trying to get the video short. Obviously, I'm kind of long-winded. And with the Ringo, there's a whole bunch of stuff on that robot. And so, even just going through trying to hit it point by point, the first video was like 12 minutes long. And it was like, that's just way too long. No one's going to sit through that. And so we hacked it down, and we got it down to like 7 minutes. And then we were like, it's still too long. We got to get it under 5. And so we just took huge sections out of it. We almost just took it and just cut sections out of it. I really wanted it in there and did whatever we had to do to slam it down to 5 minutes. But so that was good. We got some good feedback on our headline that we used for it, the palm-sized robot with real personality. That was something that was actually suggested by someone else that saw the preview of it. I can't remember where we put it out, but when you set up the campaign before you actually launch it, they'll give you a preview link, and it's like a private link, and so you can share it with anyone you want. They can go see it, and there's a little comment form at the top, so you can give your feedback. Hey, I think you should change this or whatever. So somebody else actually gave us the tagline. Which I think was real catchy. Let's see what else.
So you've mentioned.
I think the big thing was just trying to keep it short and to the point with something that's kind of complicated. Some other projects I've seen that they have a real simple, clear-cut concept, and it's like they're making something that's interesting, and there's not a whole lot to explain. You kind of either you get it or you don't, and there's no reason to the video more than a minute. So and those do really well too. But for technology. It's definitely a challenge to cram it all in there.
Yeah, you've mentioned the Ringo. I mean, just for the audience, can you explain, what's the main difference between Wink and Ringo? And, does Wink replace the Ringo, or should people who are interested in Wink also check out the Ringo? Is it like a bit of a more advanced stage, because you mentioned like stripping down the parts and such?
Yeah, so I've got the Ringo right here. This is actually a Ringo missing his battery shell right now. It just happened to be on my desk. And then the Wink right next to it's a little bit smaller.
Okay,
you can tell.
Smaller, yeah.
And so, the Wink does not replace the Ringo. What we did is we took the design from the Ringo, which we kind of figured out how to do this.
Sure.
And we took parts and designs almost exactly right off of that, and we put them in the Wink, and we basically just stripped off all the things that weren't absolutely essential. One improvement that we did make with the Wink is the line following sensors on the bottom.
Okay.
The circuit design on the Ringo is a little bit slower, so you can't sample them quite as fast. And so we simplified the line followers and made them like to where it's a circuit that responds more quickly, so you can sample it a lot faster, so you can see your lines quicker. And we went to a kind of a simplified version of the ambient light sensors.
Okay.
The Ringo is really good. It'll give you a real accurate reading of exactly what light you're seeing, all the way from almost direct sunlight to almost complete darkness. You can see that whole range. But that requires an op amp and some other circuitry. And so we took that out of the Wink. And the Wink, it uses a phototransistor, which is it'll get saturated if you get it into too much light, and if it's really dark, it'll have a hard time seeing things. But in room lighting, we've got it calibrated so that in room lighting, if you shine a flashlight at it, it can still see the flashlight really well and react to it. So it doesn't give you like an exact measurement of how much light there is, but you can still do simple programming tasks where you can read the right one and read the left one, and if the left one's more, then you turn to the left, and then you automatically have light seeking at that point without getting more complicated on the circuitry. So it gets the job done. So the Wink is designed to not have anything on there that would complicate matters, or like we thought of like having the accelerometer on there, which tells you when it's moving, but the code to deal with the accelerometer is a little bit more complicated.
Right.
And it's still totally usable, but not for fourth graders. So we left off anything that we thought would be complicated at all. So so basically the Wink is designed to be a real affordable entry-level robot that a lot of people can use to kind of get the basics. And once you go through all the 20 lessons, then you'll have the core of the C language. You won't know it all,
sure,
of course. Really trying to make it entry-level. But you'll have an idea, and if you're still interested in that, then I would suggest go ahead and check out the Ringo, because you'll know what you're doing at that point. You can actually start doing some of the more advanced things that you could do with all the sensors that are on the Ringo.
For sure, yeah, no, that's great, because you've created more of an entry level, a wider audience, people, an easier way for them to access the code, and then once they get those core skills, like you said, through the curriculum, then they can move on to the Ringo, and all the skills they learn on the Wink, that's transferable straight to the Ringo, and obviously that, I mean, the Ringo's also, does that come with a curriculum as well, or is that more like kind of learning as you go along in the open community?
There is a guide that we wrote up for it. I think it's about 60 pages, so there is quite a bit of information there.
Okay.
And it takes you through the beginnings of installing the software and everything, and then we do take you through some of the functions that we wrote for it, like dealing with the accelerometer and the gyroscope. Those are actually fairly complicated to deal with. You have to sample them constantly. If you let the buffer overflow, then it's not accurate anymore, and so you lose track of where you were. And you have to do a lot of math and stuff. So anyway, we wrote functions that just kind of do all that for you. So in the guide, it basically says, if you want to move in a straight line, here's the command to make you move in a straight line, right. And that command automatically goes and reads those. So basically you can kind of start from nothing, and you kind of build up from there. But it's not quite broken into like a classroom lesson plan kind of a thing. It's more of just a guide to kind of let you know how we intended you to use it. Right.
So definitely Wink is definitely a much more of a starter kit for people who really want to get into the coding. And it's not just for kids, is it? It's kind of for anybody who wants to really understand. I don't know, the kind of the thinking behind programming. It's kind of the basic building blocks of programming. Like it's like a new language. And I guess this is a very easy way for even adults of all ages to kind of get involved.
Yeah, certainly. We definitely don't want to just limit it to kids. We've actually had quite a few. Let me try again. Yeah, certainly. We didn't want to just limit it to kids. We had actually had quite a few people that have messaged us through Kickstarter saying that they'd always wanted to kind of play with this sort of thing and didn't really know where to begin. So they're kind of jumping into it too. So yeah, I think for anyone that's interested, we're going to try to make it just as easy as we possibly can, to where you kind of you kind of get it. By the time you kind of go through the lessons a little bit, you'll kind of see how the language is structured, and hopefully realize that it's probably not anywhere near as complicated as you might have thought.
Right, and where do you see the Wink going, and kind of where do you see Plumgeek Robotics Where do you see the future for you guys? Because you've obviously you've had one successful Kickstarter, you're about to have the second successful Kickstarter, and what are your plans, please?
Well, we're just kind of making it up as we go. This whole thing started. We were actually going to do the robotics thing in addition to the previous business that we had of doing the camera electronics, and we had an opportunity. We had an offer from another company that already makes that sort of thing to take that off from us. And we said that's a great deal because we can really focus full time on doing the robots now. We already knew that Ringo was the Ringo campaign was already going or was about to go, and we felt pretty good about it. And so we're just kind of taking it one step at a time.
Sure.
We have probably 3 more designs that are on the table right now. The next one's going to be quite a bit bigger. We're going to kind of go the other direction. It's going to be a little more advanced, and we're really excited about that. We've kind of got what we think to be kind of an interesting form factor.
Sure.
That I haven't seen out there yet. So I think that's going to be pretty exciting. And we've had lots of feedback from people on the existing robots. So at some point, we'll probably do something that's maybe like a Super Ringo or something like that. That'll add some more stuff on there. So we definitely have some ideas going forward. And if we just continue getting enough support in what we're doing to to continue to maintain the shop and continue doing it, then we'll keep doing it full. And so that's kind of the big push for us is just the fact that we get to do this kind of as a family. It's myself and my wife that run most things. We've got a couple of employees that are kind of, you know, may as well be family.
Right.
That we hang out all the time, and so we just have a good time, and it's kind of generally pretty low stress, and you know, it's better than, you know, doing other jobs that, you know, all of us could be doing. So it's fun that we come in and get to tinker around and build robots. I mean, who doesn't want to sit around and build robots all day?
No, it's pretty awesome that, you know, it's pretty awesome that, you know, now that, you know, you guys are just enjoying your work. And when it comes to it, of course, like, you know, you guys got the workshop. You've obviously said that you've moved on the other business from the camera thing, and you're trying to focus full time on this. And obviously, it is a business at the end of the day, or else, you know, you guys have obviously got a massive passion for this, or you wouldn't have done it in the first place. But what about, you know, channels of sale for this thing? You know, of course, it's great for the crowdfunding campaigns. You know, you raise the money, but there's obviously, like, there's a whole world out there of people that want to learn code. So I'm just wondering, you know, what kind of future do you see on the business side of things rather than on the creation side?
Well, we're starting to get plugged in with educators. We've already been contacted by various distributors in other countries, so we're just kind of an open door right now. That anyone that's interested in kind of getting involved in this with us or helping us distribute it or whatever, they're welcome to contact us, and we'll just kind of, you know, follow those doors as they open. As far, I really kind of right now my big push is just to get them completed, get through Kickstarter, get the lesson plan together. I'm really hoping to get some feedback from the backers, and also all the educators we've met. We'll send out the lesson plans to them and kind of see what they have to say, and just kind of get that solid. And then from there, we can definitely go on to see, like, could we take the exact same product and make it maybe more of, like, you know, learn to code. You know, I mean, it could even be a book with a robot inside of it. I don't know.
Sure.
You know, whatever ideas come along, and I'm always open to feedback for anyone that has any suggestions to improve it. Or, you know, like I said with the Ringo robot, when I would meet with people, is that I think this is a good platform for education, but I'm sure it's not the perfect platform for education.
Sure.
So, you know, let's take what we have, and, you know, if there's a way to make it the perfect thing, then, you know, we'll do that next time. So I'm open to continuing to evolve things.
Definitely. Okay, so since you got on the Kickstarter platform, and since, you know, you guys launched, have you backed other projects? Have you found projects that interest you in the Kickstarter universe?
Yeah, I have. I've actually backed quite a few others. I go through from time to time, and I just kind of whatever catches me. I don't really back a whole lot of the technology stuff. It's more like kind of artsy stuff that I find that I'm into.
Okay.
Some of the stuff that I think is a really good idea, like I backed a printer that prints circuit boards on your own bench, and you know, it wasn't something that I really needed or that I could afford, but even still, like a lot of those, like I'm happy to give them, you know, $10 or $20 to say, hey, you know, good job, and you know, to support them. The projects that I tend to back that I tend to go a little heavier on are things that I think are more kind of like community awareness type things.
Okay.
There was this great project of these kids that built a skate park in New Orleans.
Okay.
And the city came along and demolished it, and they wanted to rebuild it the correct way. And so that was like something we gave quite a bit to, just because we thought it was really great to see people going out and kind of, you know, doing their own thing, and, you know, just doing something awesome in the community. So.
No, yeah, that's the great thing about Kickstarter. I always say that, you know, it's a very unique platform. It brings communities linking to communities, and it's just one big community. So, you know, with your project, I guess you've met a lot of people, you know, a lot of people who are passionate about what you guys are doing, and obviously giving you that valuable feedback, enable for you to make the product as best as it can possibly be.
Mm-hmm.
Okay, so
yeah, the Kickstarter community has been huge. I didn't realize there were that many. I didn't realize the Kickstarter community was as big as it was when we started doing this. I thought it was just a few people that were kind of like, I guess when we first approached Kickstarter, I assumed it was a little smaller community. And once we got plugged into it, we realized how many projects there were, how much was being raised for all these projects when you start putting them together. And it really is incredible. And I really think it's just kind of the wave of the future. crowdfunding has so many advantages over other things. I mean, if you've got an idea that isn't going to work, then you'll know it ahead of time before you invest a bunch of your own money in it. When the funds come through, I mean, that's your funds. You've got it free and clear. You don't have to pay it back to a bank.
Right.
There's so many benefits to doing this, and I'm really happy to see Kickstarter do well, and the other crowdfunding sites are doing well also. But I'll always be a huge supporter of Kickstarter for sure.
Yeah, I mean, so you guys some projects, they bring on marketing teams, other advisor teams in order to kind of like potentially take bring the product to the eyes of as many people as possible. But am I incorrect in saying that you guys pretty much have handled everything by yourselves?
Yeah, we pretty much ran the whole thing ourselves. We definitely got lucky. A few things that worked out for us is on the Ringo, we got a staff pick on the Ringo, and we also got a staff pick on the Wink, which I thought was amazing. I didn't think we'd get two back to back. That goes along with
the Wink's a staff pick as well.
Yeah, it is. I was actually going to need it. I was wanting this weekend to update the little seal on there.
Okay, you're right.
I was leaving it off because whenever Kickstarter features a project, they usually will grab a project that doesn't have the seal already on there. So I was giving them some time to feature it, and I don't think they're going to. So I'm going to go to put the seal on there now.
Right. Okay. So just kind of finally,
I kind of cut you off. What were you saying about the staff pick?
Oh no! I mean, I saw that Ringo got a staff pick. I guess as a Kickstarter user, I guess I'm always looking for that seal, and that's kind of strange because it's not the seal that tells you have it. It's kind of where they put you, isn't it?
Yeah. It's once they do that, I don't know how the algorithm works that sorts sorts things. You can look specifically for all the staff picks. There's a sort that you can do where you can look at all those. But it does tend to come up in the listings a little bit higher and more often. And I don't know how much more often it comes up, but whenever you go look at any category on there, and you'll see probably a few more projects with the seals on there up on that first page or towards the top.
Right.
So that's just we got lucky, and obviously they like what we were doing. I don't know how to give anyone advice to make that happen.
Right, sure.
It's just one of those things that happens. That's definitely a plus. But as far as the other marketing we did with Ringo, we went out and reached out to blogs and everything. Of course, I read a lot about doing contacting of blogs beforehand to kind of know how to format things. You want to keep it kind of short and sweet, and not hound them or anything, and obviously be real thankful whenever they do share your work.
Sure.
I'm trying to think if there's anything else that was really significant in doing that. One of the things is that we started doing updates right away, and so we started doing kind of like little behind-the-scenes things in our shop, and nothing too exciting, but it was enough that the people, I think maybe the backers kind of connected a little more,
right?
And I think that caused them to naturally share the project with more friends, and I saw a lot of them. People sharing it on social media, and that certainly drove a lot of backers also.
Oh, so you guys were quite active on the social media, the Facebook, the Twitter platforms?
We weren't super active ourselves. I would post from time to time. I kind of, through the campaign, I would do like little updates like, hey, we're here, or hey, we're going to do this now. And just like little stuff like that. But it was the fact that I think that other people were starting to get active, and they were starting to get excited about what we were doing. And so, other people would go and share with their friends.
Sure.
And so, of course that, whether the person has, 30,000 followers or 20, that a lot of times, like, those, even people that, you wouldn't think have a huge network around them, those are their close friends that are into the same thing they are. And so, every time, somebody shares your work, that's going to definitely, drive more interest to your project.
Okay. So, Did the first project surprise you in how much you raised or your expectations? I know you guys have kind of low goals considering the technology category.
Yeah, the very first one we did, the goal was 12,000, and we figured that was going to be the absolute least that we needed in order to justify putting the time into actually making them. we already kind of decided that if we raised anything less than 15, maybe high teens, if we were anywhere in that range, we probably would just build them for the Kickstarters and send them and say thank you, and then we probably wouldn't have continued making them after that.
Right.
Because when you're the whole idea without having to go to a bank for a loan or whatever is that you take that cash that you get and you got to build your rewards and ship them, but you have to use a chunk of that money to buy enough to build more robots now.
Right.
So it's like you're not just building, if you have to build 100 for Kickstarter and you're going to keep going on this as a business, well, you really need to be buying, 200 or 300. And so the first 100 go to Kickstarter, but then you got your parts to build your next couple hundred to keep your cash flow going. So like you said, it's a business, and if you don't have money coming in, then you got to close down your shop. So so that level of the 12,000 was what we needed to just kind of get it going. And we said, let's just see where it goes from here. We had our other business still at the time, and we were just seeing where did it go. But yeah, to answer your question, I was really surprised to see it go that high. I thought that we might hit 30, maybe into the 40s, but we actually went all the way to 85.
85, that's right.
And yeah, so that was a heck of a 3 weeks. I mean, we were just kind of calling it off as it was going, and then the last couple of days we saw a huge spike too. We were at, I want to say we were just over 50, maybe. I think we were in the mid 50s, kind of coming up on the last few days, and so we said, well, we might hit 55 or 60, and that last couple of days it just took off.
Right.
When you're looking at projects, you can, if you want, you can star a project, and it kind of just marks it as like I'm interested in this. And then when you get towards the end, when it's within a day or two of a closing, then Kickstarter will start emailing you and saying, hey, this project you liked is going to go away in a couple of days. Do you want to go get on it? And so in your backer dashboard, you can also see how many people come in as a result of that. And we got quite a few at the result. So if you're on a campaign, you're coming up to the end, then know that spike can still happen at the end. So, you use it for all it's worth. And then for the Wink, when you fill out the form to start a Kickstarter, you talk about setting your goal. They say set the lowest amount that you need in order to get the job done, and if it's more than that, then great. And so that's kind of where we were with the Wink, because we already have almost all the parts that we need to build these things in stock, because they're the same ones we use on the Ringo, and we've got those in stock. And so we said, well, there's no tooling on this one, because we're using anything that's got custom tooling. We copied it straight off from Ringo. And we've got a few thousand of those pieces upstairs right now, so there's no worries there. And so we thought, we were really just getting a lot of circuit boards and some stencils for our stencil printer to actually fab them up. So we didn't need that much. And so, I didn't really know. I thought, this could be just a little thing that, a few people like, and because the cost is lower, so we obviously need more backers to hit the same reward.
Yeah, right.
But yeah, it's taken off right now. We crossed 60 this morning. And we're kind of crossing our fingers. We're hoping we might hit 100 by the end. That's kind of our goal. We'll see. We'll see if it keeps up at this rate, and we'll be over 100, and that would just blow me away. A silly dumb little idea that we had that turns into something that blows into that.
Well, the main thing is it's got you into this business. Like I said, it's kind of like it's your passion, and it's great that you can kind of like turn that into something profitable, as well as something that. It's not that expensive to buy these things, and what you gain from it. I mean, obviously, learning the basics of C language for something like $50, $60, it's not much of an ask from people, and there's a lot of fun to be had along the way, a lot of discovery.
Yeah, I can remember when I was learning IT back in the day. I used to do networking, and I used to do some database work, and I remember you go into Barnes and Noble to get like one of these certification books or whatever. And, it wasn't uncommon to drop $50 on a textbook. So anyone that's ever gone to college knows that $50, $60 for a textbook is not that much. So yeah, when you put it in that context, yeah, certainly.
And, you've mentioned a lot about building these things. I mean, are you manufacturing them like in-house and over where you guys are in Portland? You guys are literally going to build each and every one of these Winks?
Yeah, we sure do. Actually, here, I'll point the camera over here.
Sure,
see if you can see. Here's our, okay, that's my desk. That's terrible. But over, okay, so over here, the back side of this thing that you see right here, this is our stencil printer.
Okay.
And basically that puts solder paste on the board, and then it kind of blends into the background. But there's another machine over behind it, which is our pick and place machine.
Oh, pick and place.
And that actually picks up all the parts off of the little tapes that they come on, and sticks them on the boards. And actually, if you go check out our YouTube channel,
sure,
the Plumgeek YouTube channel, there's a video that we did a few months ago where we went through that process because people started asking us about it, and we thought it'd be a fun little update to do.
Yeah, that's awesome.
So you kind of get the machine go and everything. We have the circuit boards actually made overseas. The process to fab up a circuit board is pretty involved, and lots of ugly chemicals and big routers and stuff like that. So it makes a lot more sense just to get the boards. But we get the boards, and then we get the parts. And some of the parts come from U.S. sources. Some of them we get overseas. And once we get them all right here, then we actually do populate them all on the board. Then we have an oven that we cook them in, which actually reflows the solder. It liquefies the solder and solders all the parts down. That's the normal way to make any kind of electronics like that. And then in the back over there behind me, we have the assembly room, or the assembly area for doing all the through-hole parts. So we have a few solder stations and lights and microscopes. And so all the little through-hole parts that actually go through the board, like the little lights here, you can see it bends, it actually goes through the board. So the machine doesn't place those, so we actually have to hand do those. So we'll hand solder the lights on, the little sound chirper. We put the batteries together over there. We put the cover over it. We solder pins onto them. So we do all the final assembly over there. And the table right behind you, which is covered in junk right now, is where we do all the programming and testing. There's a little test platform right next to it there that has like requirement lines. So when we do the little test, it drives in a square so we can make sure that works, and we can test all the sensors with it. And then we program them all up on the computer. And then once they're done with that, then they go to our center table right here, and my wife Nona goes through and she does a final like visual inspection on everything. She cleans them all up real nice and packages them, and then the shipping computer is way over there behind me. Okay. And that's where all the fun happens, where we put them in boxes and send them out the door.
Well, that's pretty awesome. That you're conceiving the idea, you're prototyping the idea. You're building the prototypes of the idea. You're then writing the code for the idea, and literally, you're manufacturing the idea and then shipping the idea all in one location. It's pretty fantastic.
Yeah, I think that's definitely the way things are going with the maker community, and having more and more tools that are available. I mean, you got 3D printing is just taking off like crazy now. There's so many things you can 3D print now, and even economically and quickly. So the ability for people, especially with open source, is that you can take a lot of these fairly complex, hard-to-reach ideas and pieces and designs, and you can put them together. And you do need a few different people with a few different skill sets. But the idea, once you have an idea and you put it together, it's like taking the next few steps to actually build the thing is getting easier and easier, I think. So I think this sort of thing will probably, for anyone that's on manufacturing anything on a small scale, I think this is probably something we'll see more and more going forward. It also kind of comes together with the whole, the sustainability movement of, the idea of trying to keep everything together local. And of course, still the parts have to come from all over the world. So, there's, that problem still needs to be solved. But I can see more and more of like maker spaces and like the idea technology incubators, all kind of coming together with all these the right software and the right machines and the right everything kind of all together, so that you'll have these little hubs around. I'm kind of imagining that in the future you might have these little hubs where people come together with all this great knowledge, and between all of them they can create something that they can actually go and sell and use that to they can pay their living that way. They can pay for the building and have a little business going. So that hopefully that'll happen in the future. I think that would be really exciting to see.
Yeah, obviously a lot of maker spaces and things have been popping up, and it's really getting more and more popular. Although it is still niche, it's got a lot more popular than it used to be. Some huge barriers in kind of making things like, I don't know, even small robots or anything to do with electronics. There's still barriers, but these barriers have been brought down heavily by, obviously, like you were talking about, in-house equipment and obviously even fast prototyping overseas. Because I'm sure that you guys get your design out there, and you said what was the lead time, about 7 days, 10 days, you've got your boards in your offices, right?
Yeah, actually, there's a couple of places that we use the boards that we. It's actually kind of funny, but we use this. We use a service that's right here in Oregon.
Cool.
That's a quick turn board service, and we can get the stuff back in like 2 days. But the problem is they their quick turn service that it's low cost, it's great boards, but the only color that they'll do is that god awful green solder mask on the boards. And so if you're gonna bury your circuit board inside of an enclosure or something, that doesn't matter. But with our products being that the board is kind of the feature and everything's all open and exposed, I don't want to do a Kickstarter with that terrible green board.
Sure.
So we end up having to send those off to the factory that we get our production boards from, because they can do any color we want. And the lead time on that is usually a week and a half to 2 weeks by the time they build them. The shipping time from the time they ship them to get them to us is pretty much overnight. It's amazing. DHL from China is pretty quick. They're like, oh yeah, we shipped it, and you expect it to arrive in 2 weeks, but no, it's there the next morning or the morning after.
Yeah, definitely. So do you have any kind of, on a last point, do you have any advice you can give to other people who are looking to launch a project on Kickstarter? Not necessarily in the space. I know that your specialization is kind of like the maker movement, but just in general, from all of your experiences that you've had, is there any advice you can give to somebody?
I would say definitely engage with the backers. We go through and every single person that pledges to the campaign gets a personal message back. I try to talk to a lot of them personally. Every now and then somebody will kind of catch my eye, or like I'll click and I'll just kind of see like what other things they've backed or whatever. Maybe just something about what they backed, or they left a comment or something, and so I'll just click on their profile and see what other projects they've backed, and sometimes I discover other interesting stuff that way myself. And so I might like ask them a question about it or whatever, and I've had a few people kind of get surprised, like, oh, I'm talking to a real person. And so I think that people really appreciate that. So definitely engage with the backers. Post lots of updates, even if it's just silly little stuff. Even if it's just like a side thing that's not really even connected to your project, because they kind of see you as like a real person. And I think a lot of people are used to dealing with companies that are just kind of faceless, and they really don't care about their customers, and you're just a number to them. And with the the crowdfunding community, it's much more of a kind of a family. So where I think that letting people see you as like who you really are and being authentic, I think that's huge. Make the video as short as you possibly can. When I was going into this, I read a lot of stuff that was just like general advice I found online, and I came across. I don't have a link to it. I was looking for it the other day, but it said that whenever you're selling anything, and especially with the crowdsourcing, is the minimum effective dose. And the idea is to present whatever the minimum is necessary to get the idea across, and to let the person determine whether they have an interest in this or not. And then all the other like extra facts and everything, all the technical details, you can put that down below in the campaign. And anyone that's really interested in that, they're going to go down and read those details. But that was kind of the feedback we got from our first video, too, because we tried to tell them everything about the robot. And people were saying, like they don't want to know everything about the robot. They just want to know what can it do. They want to see it go, and either they're interested at that point or they're not.
Right.
And so for the main video, just try to keep it short and sweet and to the point. Make sure you have good pictures. If I did photography before, so it's a little easier. It was easier for me. But look up some, if you have a little product and you're trying to get some pictures of it, just do some Googling around for how to take product photos. You can do some amazing things just by holding a bed sheet over a window and using that to diffuse the light and getting a nice picture of everything.
Yeah.
So just take some time and present it well. I've seen some Kickstarters that didn't seem to be doing so well, and when you kind of look at the pictures and stuff they have on there, it's just it didn't look like it seemed like maybe they could have put a little more time into just trying to neaten it up a little bit. And so the common sense stuff like that. But yeah, I would say that I guess the best advice I could give is if you're thinking of doing a Kickstarter, to do it and just see what happens. It might go nowhere, and it might turn into something awesome. So you don't know till you try it.
Right. Okay. Well, Kevin, thanks so much for your time, and thank you for really going to the guts of your project and telling everyone about it. And we really appreciate. And honestly, we wish you. Honestly, for myself, I can say I think your project's pretty awesome, and I wish you the best. And I'm hoping to see more from you guys in the future.
Well, great. Yeah, thank you so much. Thanks for having me.